So starting over. So I'm Jack Marvin.
Oh, I'm Trevor Hammock.
And we're going to tell you about a tool you can use to select tests based on codes that changes. Next slide. So what's so good about it? And that's one thing we'll talk about. Another thing we'll talk about is what things you have to watch out for. And the last thing we'll talk about is who can use it.
Okay, so basically the benefits of selecting tests with code coverage. Obviously, the biggest advantage, you're running less tests. In our experiments, we ran on average anywhere from like 50% to 80% less tests, which if you have thousands, tens of thousands, God forbid, even 100,000 of tests, that saves you a lot of time and a lot of hardware. Also, what we noticed in our experiments is that it really depends on your risk tolerance and confidence. For instance, like when you want to use code-based selection, code-based test selection versus not, how aggressive you want to be, and like what you can use with it. Also, another factor is like the code change frequency. For instance, if you have developers that are checking things in constantly, there's a good chance you might have to run more tests, or you might not be able to select as many tests, especially if they're more aggressive about it. And obviously the developer experience level. For instance, if you have developers or guys that are more confident in their changes, or they're not checking in as many bugs, they can probably be a lot more aggressive and use this approach a lot more often. But you have someone who's a new developer, you may not want to risk it. You might want to use the standard test selection-based ways.
So if you're a developer, you're always under a crunch trying to get your tests run so you can check your code in. Well, if you're running less tests, if you can focus test on what the change is all about, you can do that a lot sooner.
Yep. So some more advantages. So one of the biggest advantages for code-based test selection is it only focuses on the changes. So for instance, if you have 100 tests and you only have like 10 tests that affect a certain feature, only run those 10 tests. I mean, technically, like the other 90 could regress, but the odds are they won't. And if you actually do run them, you're going to find out that they don't. So it's basically makes things a lot more efficient. You get earlier confidence in changes. So for instance, if I only know that 10 tests are affected, I'm not going to sweat as much as if all the 100 tests out of 100 are affected. And also I'm going to probably get quicker turnaround times because I'm running less tests. Yeah, and also, for instance, there are rare instances where sometimes someone checks something in and actually little to nothing changed, like maybe like 0 or 1 tests. And those are great scenarios because you don't have to run anything and it, don't have to risk anything.
So if you're not running as many tests, you got a lot of idle hardware you can either turn off, or you could do other additional testing like exploratory. If you're QA, then you could decide not to release sooner because you say it's done. There's less test run, they run a lot faster. A huge benefit I see is reduce false fails, right? We have these flaky tests caused mostly by resource contention. Well, if you don't run those tests, you're not going to see those flaky fails. No, it's all right.
Yeah, so just to add on before we go to the next slide. So what we mean by exploratory is you can do forms of testing you never thought possible. Like for instance, in our scenario, we actually made it an automated script to where when someone checked something in, we basically had like continuous integration to where we automatically ran tests. And normally that wouldn't be feasible because we just have so many tests that like they could take up to like a full day to run when there's check-ins every hour. But because we have code-based test selection, we can actually like test each individual check-in by running less tests and actually be able to do something that we weren't able to physically do before. And that's one of the advantages of using an approach like this. Yeah. Okay, so another advantage from code-based test selection is reducing redundant fails. So for instance, especially from the company we work with, a lot of times like we have thousands, if not tens of thousands of failures, but we have tests that are very similar to where they all fail the same way. So for instance, we have to technically go through each one and validate, hey, is this the same? Is this different? If they are all failing, are they all failing the same way? Are they the same bug, a different bug? And this just adds a lot of headache and pain. And a lot of times we have to like spend time going through each individual failure. But with code-based test selection, technically, if we know the coverage or the mapping of like features to test, we can be like, hey, we know all these tests test the code the same way. We all know they're going to fail the same way, so we don't have to process as many. So it allows us to reduce the redundant failures and make the processing of the tests much easier. Also, another little benefit is it allows us to identify tests that rarely fail or don't fail. So for instance, there could be like code from like, the 90s that someone wrote that, hasn't been changed or updated and is really stable. And, you could make a case that, do we necessarily need to have that test anymore? And you can possibly use that to like prune and like adjust your test suite accordingly based off of your resources. And basically another huge advantage with this approach is you can also detect or you can quantify tests using coverage metrics. So for instance, if you have like one test that covers like thousands of functions or another test that only covers one function, you technically know which ones are better than others, or if one covers like more lines of code than the other. Technically, you can quantify that and actually use that to prioritize tests. So for instance, if you have 100 tests, but some of them are better coverage tests than others, you can actually prioritize and run those first. And assuming you get the results first, you can actually get failure analysis a lot quicker. So that's one huge advantage as well.
So some other benefits you can have is you can find out which functions are the most common across tests, and maybe you might want to focus on that for your coverage. Maybe find out you're missing some tests possibly. You can find out if you have a lot of code churn, how stable the release is. So if you have developers constantly making changes to one function, maybe that's an opportunity to say, maybe we want to look at this function and see if maybe someone else could look at it, maybe to optimize it or affect the algorithm or refactor, that kind of thing.
Yeah, and then as I mentioned, we mentioned like on a slide or two ago, you can basically quantify a change's impact. Basically, you can know, hey, does this actually affect any tests? Does it not? Does it affect everything? Does it affect like things that are like, oh, if this breaks, the world ends. And also you can use this in multi-team flows. So for instance, like if you have like upstream products, you can actually like annotate your code for that and be like, hey, this shared code base or another product team is going to affect my product. I can see ahead of time, hey, this is going to affect my test or affect my product, and use that for also testing base selection as well. Even if you're not like necessarily following or like up to date on like everything that other product team is doing.
Right. So now we'll talk about some of the things you have to watch out for, some of the risks. So it's always guesswork. You perfect the algorithm to select your tests, but it's software, right? It could have bugs too, right? So you got to be careful there. And then the worst risk, of course, is if you're not running all your tests, well, how good is this tool? Am I really missing something? That hasn't happened to us yet, but I mean, it could happen. That's a risk you got to be aware of.
So basically some more risks. So obviously like in your release cycle for your product, like for instance, like daily, like normal, like individual, like hourly, like daily check-in changes versus like releases versus like patches. We all have different ways we test those different releases and which ones we feel comfortable with. Like for instance, in our case, in our production environment, we're using code-based selection to test top and trunk changes, but we necessarily haven't moved over to the patch or release stages because, at least for us, we have stronger testing requirements for those ones. But you can pick and choose and use one for the other. And also another, once again, potential issue that we mentioned before is like cross-team collaboration. So for instance, if you have like code bases that are shared, and for instance, like you have like a downstream shared code base where, hey, one of my developers made a change that could affect another product. Well, technically, they might not see or know that ahead of time. And actually, a lot of times, like, as we'll mention later, sometimes you like to cheat with code base coverage and you don't like to fully annotate the code base to save time. And if you're purposely not annotating for other product groups, that actually could be a blind spot. And if someone makes a change in that blind spot, you may not see that change necessarily.
So some ways you can think of to limit your risk. So this tool works really well, but maybe you want to start, let's say you do nightly builds. Lots of people do that. Well, maybe start off with using this tool for one of those builds, right? And ramp up as you gain confidence. Another thing people have done is they will not change anything, but add this tool and then say, if the regular run found bugs, did this test tool also find those same tests that found those bugs? And as you mentioned, so revenue releases, like quarterly releases that we have that customers get, we kind of shy away from that for now until it's a lot more stronger, proven.
So basically, who could benefit from this sort of approach? And the thing we want to drive home is basically everyone can benefit from this. Obviously, the one we've constantly mentioned is developers. So they could use like this approach or like a tool, basically say, hey, I need to know what to test, or hey, I want to use a smoke test. Well, they could use this approach to basically run as few tests as possible, get quick turnaround times, and only need to run what they need to run. Obviously, for QA, we see the biggest benefit from this because we constantly have to run tests and validate changes. So for us, being able to run tests quicker or be more efficient about what we do can also make us better at our jobs. And also one that we've sort of encountered is marketing. But basically, like for instance, there's needs to be like a patch for like your particular product, or like you need to like deliver something to a customer. Well, marketing could actually use the analytics from a tool or approach based like this, because they can basically say, hey, this particular feature that we're trying to get out to a customer really quickly, it affects all the tests. We're probably going to need quicker turnaround time in case QA finds a bug and developer needs to make a fix. So maybe we give like an estimate of like 10 days, but like if like little to no tests are affected, like maybe like 5 out of 100, they could be like, well, this is really minimal impact. We don't think it's going to be really hard on QA. So they could give like an easier estimate, maybe like 3 days instead. But basically everyone can use or benefit from this sort of approach.
So how does this tool work? Well, it's all based off of code coverage. So we use gcov, it's on Linux, and you get a analysis. You instrument your code for what you want to run, and you run your tests, and then you make a database, it stores the mapping of the code to the test. And then you want to go run a build. Well, there's some code changes in that build, and you say, what changes are there? And you look up in your database to see which test those changes are covered by.
And before we move on, basically out of these 4 steps, all of these are pretty trivial except for the third step, which is the hard part, because you have to do the code analysis and figure out, hey, where all the lines are, where all the functions, how are they different from the code coverage I extracted earlier? And also you have to do this on a per language basis. And that really, this is the thing that kind of like hinders the possible rollout of using like an approach or a tool base like this, is you have to be almost like a compiler basically in order to successfully do code-based coverage. So additionally, like we also timed out all the individual steps. For the most part, technically there were 4 steps, but 2 of them can be condensed down. So the first step is actually like annotating the code and running the tests. Generally speaking, it's going to be longer than your normal regression run. So for instance, if your normal test suite takes like an hour to run, there's a good chance it's probably going to take like 2 to 10 times longer than normal. But also depends on like the number of tests you have, your code size. But in general, it should always just be longer. So you just need to expect that. Database creation, once again, this is basically you just go down, look at your results, extract all the data off disk. Generally speaking, this is like IO bound because there's a lot of data to work with, but generally speaking, it should take at least half an hour to 2 hours, at least in our case where we have like tens of thousands of test cases, but it's relatively quick. And then finally, the test list creation. So this is analyzing the build changes, figure out what functions changed, and returning the test list. This part's actually relatively quick for the most part. However, at least in our scenario, due to like security reasons, we have to like sometimes actually download source code over the network. And that's mainly why like there could be a bottleneck and it could take like up to a minute. But for the most part, this step's instantaneous, so you don't have to like wait an hour to run tests that run in an hour.
I would also add to this slide that the last step is what your end user has to do. The database creation and the regression run, I mean, those only have to happen once, and then you can use that same data for many builds. And okay, next slide. So another issue with this approach is you do a GCov run, code coverage run, and you get your data. Well, you make a database. Let's say you do that a month ago. Well, a lot of code has changed since then. So what do you do about that? One thing you can do is do regular code coverage runs. Another thing you can do is you can just, you have new tests, you can select those to add to your test list that's created here. And what's important for us too, though, is the product the features that have been shipping are a lot more critical than new features. So it means no regressions, right? So that's an important thing to keep in mind. Even if testing with the old data, you're still covering that the old data still works.
Yeah, so before we move on, you guys are probably thinking, hey, how often do I need to constantly update the coverage? So for instance, in our case, in our testing, so initially some background for this project is we already had a flow or requirement for management to where we had to have like coverage metrics for every month to know like the line coverage and function coverage to know like if we were, the test suite was always like up to date and making sure it's covering everything. So we actually hooked into those processes and basically we're regenerating our coverage basically on a monthly basis. And thus far it's worked for us, but obviously like, once again, for at least like in our scenario for like our groups and our products, our code base is very stable. So like we haven't necessarily gotten burned on using or updating on a monthly basis. But it's worked for us and it could also probably work for you as well, but it just depends. So other limitations. So what is the optimal set of tests? So as we mentioned before, like you technically have the coverage metric and you can use that to prioritize tests. But the issue is, what makes a test necessarily better than other? So for instance, like, do you want to go for like the fastest running test? Because a lot of times when you're doing code-based selection, you want quick turnaround time because you're running like a smoke test basically. But there could be instances where you have a bunch of like fast tests that don't really like cover anything, like for instance, like error tests that fail immediately. But then you also have this weird scenario where maybe you want to like maximize coverage. Well, a lot of times those could be like bigger, larger, maybe possibly even performance tests that take like hours or even like days to run. And, well, those technically cover the code better. So you have to like, based off the scenario, you may have to like select or like run certain tests or others. And there's really, the approach really just depends on like the context and the team and what you're doing with. And there's also like other requirements or possibilities like in our at our company or our products, memory is a big one. So like trying to like run tests with like little memory, because generally speaking, those machines are easier to like run and also acquire, but also at the same time, like if you're like trying to check a memory leak or like validate that, technically you may want to use like bigger tests or get bigger machines. But once again, pros and cons to what is the most optimal set of tests you should be prioritizing.
So some other limitations. Well, one is if somebody makes a change to a function in a piece of code that all your tests cover, well, it's going to hit all your tests. So you may choose to filter out some of those, but that of course can add more chance of finding the defect.
But I guess one thing we probably want to highlight here is that, as we mentioned, like an earlier slide, we on average ran 50 to 80% less tests. But there's going to be times where someone's going to check in like in main state and you're just going to have to run everything. Or there could be a time where like, it's the holidays, no one checked anything in, and technically you don't have to run anything. But technically speaking, there will be times where you still have to run everything. Another limitation is rare occurring defects. So for instance, if there's like an issue, like your code generates a SIG folder, like 1 in a 10 chance, it has a chance of like spitting out like a slightly different value or getting corrupted. Those things could be problematic for code-based selection. I mean, granted, there's still a problem in the normal environment, but because you're not always running your full test suite as often or delaying them or possibly running tests later, those issues are also going to be discovered later. So for instance, if you normally would have discovered it immediately or a couple of days later, you might not discover it till like weeks, if not months later. But generally, this is also just a general problem, but it's something to be mindful of when those situations do occur.
So this tool that we chose, it covers C++ code, which is what most of our code is. But some of the code is Python or Tcl, or could be some other kind of language. And those are going to be blind spots. You're not going to know about coverage for those. Another issue is if you choose functional or line coverage. Well, functional is a lot easier because it's a lot less crazy changing. So, but you don't have as much accuracy either. So there's trade-offs there. I mean, I don't think we'll ever do line coverage just because he would disagree, but it changes so much.
Yeah, and just to add on to this, because I'm partially the guy who coded the tool that we did all this testing on, is it's really, really hard to accurately use line, because technically, at least most languages have grammar that ensure that like functions are uniquely identifiable. So for instance, like if we're constantly updating your coverage like month to month, for the most part, like the functions and the functions names don't really change. But for instance, a line, technically, there's no like grammar guarantees by the language that things are going to be the same. Like, for instance, you have a line that's like A plus B, and then some developer like rewrites the line to be like A plus B plus C. You know, is that the same line? Was it rewritten? Was it like shifted down? Was it deleted? And you just have these scenarios where you can't, you know, guarantee that the line in one particular build compared to another is necessarily going to be the same, which also just hinders using line coverage. And you might have to use like a more advanced like machine learning based approach to accurately select by that metric. So basically in conclusion, although that, you know, in our scenario, we're not using this for like official releases or like patches, but like for using our normal like daily testing, we've significantly reduced the number of tests. And for the most part, you know, we haven't missed anything. There hasn't necessarily been any sort of like failures or bugs that haven't been caught by this approach. And we've been able to save a lot of hardware and time by doing this. And basically, as we grow more confident, as like, and we find ways to like improve this approach, we hope to like use this for other stuff, like for instance, the official releases or like patches and whatnot for things that we normally want to be safer with. And also it allows for new forms of exploratory testing or using data in ways that we weren't using necessarily before. And that's basically our presentation. Yeah, if anyone has any questions. The specific tool that we use internally, we call it a DTS, which is Dynamic Test Selector. But basically, like you just have to make a tool that basically extracts coverage and, you know, successfully analyzes your product or your builds and tells you what changed, and then maps it particularly to like a database or the data you have. So are we doing requirement-based testing?
So yes. Right.
Based test.
So as of right now, we're only linking functions to tests. We technically do have the line data, but as I mentioned, it's really hard to make use of it. We are actually still using it for analysis. For instance, we're using it to, how do I explain this? Basically evaluate which tests are better than others. So for instance, if we know there's like 10 lines in a function and we know one test covers 8 of them, technically we know the percentage coverage is 80%, whereas another test only covers 2 out of the 10. Technically we know that's 20%, and we actually store that metric in the database and use that also as part of our test-based selection to know which ones are better than others. Yeah, I've been trying, yeah. Yeah. Oh, yeah.
The traceability matrix, trace the test stack.
Yeah, so basically, can we trace the code back to the requirements? But yes, because basically this tool basically allows like an automated way to say, hey, if a particular feature is like in a function or like a class or like a collection of functions or Well, because requirements get weird because they can be also spread out over like multiple functions. But basically, assuming you can like reasonably like point like requirements to code, you can technically use this to map that to tests and use that in an automated fashion rather than doing everything by hand.
So, said that you guys exposing this to other areas, but once they're actually try to get involved.
Yeah, so the question was, are we trying to expose this to other areas in our company? So for instance, we initially made this tool as a collaboration between 4 of our different product teams. And initially from the testing, it worked out pretty well. And we've been giving a bunch of like demos and presentations the last couple of months. And I think we've expanded out to like up to like 8 teams now. But basically we're trying to use this approach to basically try to be more efficient within our own company. But just it's really slow because we're a big company. Can you repeat that? So what do you mean by record and replay? Oh, I mean, for us, we just basically just made a Python script. So we actually made the code ourselves. Yeah. So the question was, do we record and replay with the code? But yeah, we wrote the code ourselves.